Hello everyone. Am I audible?
Yes, ma'am.
Am I visible?
Only
Okay,
four.
wait. Okay, I think my camera is not working. I'm trying, but anyway, I'm first of all, I want to introduce myself. I'm Namrita, a PhD student at IIT ISM Dhanbad. So this is problem solving session week 6 for the course Differential Equation for Engineering. Oh, okay, in this session, we will discuss problems related to week 6 lectures, in which we will discuss these questions you can see on my screen. One by one, we will discuss these questions. So, you have to try with me and we will discuss. Okay, you can try question number one. Question number one says show that jn plus 1 has a root between any two consecutive positive roots of jn around x is equals to 0. So you have to show that jn plus 1 has a root between two consecutive positive root of jn around x is equals to 0. Is this question is clear?
Yes, ma'am.
Okay, please try to solve this question and tell me your approach how to proceed. For practicing more problems, I will suggest MD Rai Singhania. You can see this book for your practice problems related to your lectures. You can also follow SL Ross, which is for the concept clearance.
Madam, please repeat again.
SL Ross, you can Follow SL Ross book for the concept purpose, and for problem solving purpose, you can see MD Rai Singhania.
Please, madam, spell it, madam.
Sorry,
The author name. Please
SL
spell.
Ross. SL Ross. Okay, I'm going to write in the inbox.
Madam, title of the book is
Okay, just wait. Introduction to ordinary differential equation. Or you can, okay, simply differential equation by SL Ross. The title is Differential Equations by SL Ross. Okay, please try to solve question number 1. I think my camera is not working right now. Question is clear. So the question says we have to show Gn plus 1 has a root between any two consecutive positive root of Jn around x is equals to 0. Let us suppose x1 and x2 are the roots for Jn. Okay, suppose x1 and x2 are the roots of J and x. If these are roots, then these will satisfy Jn. These are consecutive positive roots. So these are greater than 0 and one is less than another one. We can also write as is it okay?
Yes, ma'am.
Okay. Now we will use Rawls theorem. Have you heard about Rawls theorem?
No, ma'am.
Okay. The Rawls theorem says that if the roots, two consecutive roots satisfy any function, then there exists a roots between these consecutive roots at which the derivative of function is equal to 0. Okay, I'm going to write. If these things will happen, then there exists a root x between x1 and x2 such that the derivative of the function, here the function will consider these two are function, so the derivative of the function will 0. So the Rawls theorem says that if two consecutive roots are the satisfied by the function, then there exists a roots between the two consecutive roots at which the derivative of the function equal to 0. Is it clear? You can see the Rawls theorem. So the derivative of the function is equals to 0 at any x between x1 and x2. We also know that the derivative of the above expression what is the derivative? Have you learned about these property in your lecture series?
Yes, ma'am.
Okay, we can write from the recurrence relation. So from equation 1 and equation 2, can we write Is it clear? In this question, we have to show Jn plus 1 has a root between any two consecutive positive root of Jn around x is equals to 0. So, we will suppose x1, x2 are two consecutive roots of Jn, and we will use Rawls theorem. With the help of Rawls theorem, we can say there exists a x between x1, x2 at which the derivative of the function is 0. And also we know that the derivative of function is minus x की power minus n j n plus 1 x. This we have already learned in the lectures. This from the recurrence relation. So from equation 1 and 2, we can clearly see that x minus n j n plus 1 x is equals to 0. That is j n plus 1 x is equals to 0. X is the 0 of Bessel's functions jn plus 1. Is it fine? Hello.
Okay, ma'am.
Okay. Now let's move to the next question. If there is any doubt, you can ask in question number 1. You can see the solution. Okay, I think there is no doubt. We can move. Question number 2. Please try to express. These things are quite easy. So question number 2 says express Z2, Z3, Z4 in terms of Z0 and Z1. Okay, first of all, try to express Z2 in terms of Z0 and Z1. Which recurrence formula we will use? You can tell me, and also you can tell me the answer. Are you trying question number 2? Tell me the recurrence relation. What recurrence relation we'll use in this question? Is there any relation between Zn and Zn plus 1, Zn minus 1? Because you have to express Z2 in terms of Z0, Z1. So,
Ma'am, Jn plus 1 of x is equal to 2n by x Jn of x minus Jn minus 1 of x.
yes, is it correct? It is correct answer. So, first of all, I'm going to write the question. So, we'll use the recurrence relation. or we can write it as 2n plus 1 upon x Zn x minus Zn minus 1x. So this is the recurrence relation we will use in this question to find Z2 in terms of Z0, Z1 and also for Z3 and Z4 also. So first of all put n is equals to 1. Sorry, this is 1. So this is the answer. After putting n is equals to 2, you will get Z3. After putting 2, we'll get so you have to remove Z2 because you have to find in terms of Z0 and Z1. So you can put Z2 from the above expression. So after calculating, we'll get taking Z1 outside and also you can clearly see from here. I'm just taking Z1 together and the coefficient of Z0 is minus 4 by x. So this is Z3. Similarly, we have to put n is equals to. So these type of question you can solve using this recurrence relation and after substituting for higher value of n and in terms of Z0, Z1 you have to back substitute Z2, Z3. For example, in case of Z4, in case of Z4 you will get so this is 6 in case of here Z3 you can substitute Z3 minus what is the recurrence relation Zn minus 1, so n is 3, so here 2. So what is the value of Z3? You can write from above equation. And what is the value of Z2? Z2, the value of Z2 is 2 of x, Z1x minus Z0 x. So you can simplify. You can multiply minus. After multiplying this and taking this, you will get minus 8 by x. Thus, after multiplying these things and taking this, you will get 1 minus 24 x square z naught. So this is z4x. Similarly, you can find z5, z6, any of these things. Is there any doubt?
No, ma'am.
Okay. Let's move to the next question. Question number 3. What is question number 3? Please try to solve. Find the differential equation that is satisfied by the function. We are given the function and we have to find the differential equation. Question is clear? You can try.
Is given differential equation. How can we able to find out?
Okay, the function is given, so you have to find the differential equation. Uh, have you learned what is the value of z 1 by 2?
Yes, ma'am.
Okay, please substitute the value, then you will get fx in simplified form, and after differentiating, you will get the differential equation. Try in this way. Then I will explain. The question is find the differential equation that is satisfied by the function. Anyone got the answer?
So we can substitute j of x is equal to square root of 2 by pi x into sin x.
Yes.
Then the root pi x will become cancel.
Mm-hmm. Yes.
Root 2 sin x will be remaining, ma'am.
Okay, okay, fine. Good. We know that the value of z1 by 2 x is under root 2 pi x sin x. After substituting this value in in this f of x, say this is equation star. After substituting, you will get under root 2 sin x. This will cancel out. Now you have to find the differential equation. So what should I do? We have to remove f of x. Is it okay? Okay, let's if we again differentiate this equation, what will get?
Minus root 2 sin x.
Yes. So this is f dash x. After again differentiating, you will get, you can say f of x is y. So this is y dash. So here y double dash is equals to minus under root 2 sine of x. Now using question star, sorry, not star, let's say question 1, this is question 2. Using equation 1, here this is equation 1. So this is y, not y dash. That implies we can say under root pi of x z1 by 2 satisfy the differential equation. Is it okay? Okay. If there is any doubt, you can ask. If there is no doubt, we can move question number 4. Okay, the question number 4 is, you can try. So you have to find the value of this expression. You have to just simply put the values and get the answer. Tell me the answer. We have already used z1 by 2 and z1 by minus 1 by 2 you can use.
Is it 2 by pi?
Yes, it is correct answer. Anyone else? It is quite simple. You can solve. So z1 by 2, the value of z1 by 2 is under root 2 pi x sine of x, and also we know that the value of z minus 1 by 2, which is cos of x, we will substitute these values. 1 and 2 in star. Let's say this is star. So after simplifying, you'll get sin x square x plus x into cos square x. This will cancel out. After taking outside 2 by p, 2 by pi, then the remaining terms are, the value of this expression is 1, so the answer is 2 upon pi. Okay, let's move to the next question. I think this is quite easy, so there is no any doubt you can solve. So move to the next question, question number 5. Write z 5 by 2x and z minus 5 by 2x in terms of elementary function. Please try to solve. Again, you have to use the recurrence relation. Are you trying?
Yes, ma'am.
Okay. we use the recurrence relation. Which recurrence relation we'll use?
So is it Jn minus 1 of x plus Jn plus 1 of x is equal to 2n by x into Jn of x?
Yes, the same recurrence relation which we have already used. So Zn plus 1 of x is equals to 2n upon x Zn of x. Can anyone tell me what is elementary functions?
First, we need to calculate J3 by 2.
Yes.
Then we have to calculate J5 by 2.
So we have to calculate 5 by 2. So what will be the value of n here? We have to substitute the value of n according to this.
3
That
by
means,
2.
yes, that means we have to substitute the value of n is equals to 3 by 2, so that we can find the value of z 5 by 2. So here z 3 by 2 of x is equals to, after substituting 3 by 2, 2 will cancel, we'll get 3 by x, z 3 by 2, z of 1 by 2. Now we have to find the value of this z 3 by 2. Again we'll use this recurrence relation. Let's start.
Madam, in the LHS, J5 by 2 it is.
Yes, sorry, this is 5 by 2. After putting n 3 by 2 here, you will get z 5 by 2. Now we have to find the value of z 3 by 2. Again we'll use this recurrence relation, and we'll find the value of z 3 by 2, and after we'll substitute the value of z 3 by 2 so that we can find the value of z 5 by 2. So what will be the value of z 3 by 2? For this we have to substitute n is equals to 1 by 2. Is it okay?
Yes, ma'am.
Because here z n plus 1. So if we substitute 1 by 2, then we'll get 3 by 2. Is it okay? Okay. So what will be the value of z 3 by 2? In the recurrence, we will use the recurrence relation 2n upon x. So 2n means, after substituting 2 into 1 by 2, we'll get 1 by x. Z of 1 by 2 of x minus z of, here n minus 1. So 1 by 2 minus 1 is minus 1 by 2 of x. Okay. Now we'll use this value in equation. Let's say this is equation 1. We'll use z 3 by 2 in equation 1. Then we'll get z 5 by 2. So if we take z1 by 2 outside and multiply this term, you will get, so what will be the value of z1 by 2? It is under root 2 upon pi x sine of x, and z minus 1 by 2, it is 2 upon pi of x into cos of x. So this is the value of z5 by 2 of x. Everyone got the answer?
Yes, ma'am.
Okay. Now we have to find similarly z minus 5 by 2 of x. So what should we do in this case? Again, we'll use the same recurrence relation and we'll put the value of n is equals to minus 3 by 2. So that we'll get z minus 5 by 2. Is it okay?
Yes.
Okay. After substituting here z n plus 1. So we'll get 5 by 2 minus 5 by 2 is equals to here minus 3 by x z of minus 3 by 2 of x minus minus 3 by 2 minus 1 minus 5 by 2.
Minus 5 by 2.
Yes. So you can take these together. So 2 of z minus 5 by 2 of x minus 3 of x z minus 3 upon 2. So you have to calculate z minus 3 of 2. So again we'll use the same recurrence relation. We'll put minus 1 by 2. Then we'll get z minus 3 by 2. So what is the recurrence relation? 2n upon x. So just wait. What is the recurrence relation? This is the recurrence relation. You have to substitute n minus 1 by 2. Is it okay? N is equals to 1. If you substitute n is equals to 1 by 2, you will get 3 by 2. But you have to find minus 3 by 2. What will be the value of minus 3 by 2? You have to substitute minus 5 by 2. Am I right?
Yes, ma'am.
Okay. So 2n means minus 5. 2 to cancel. I think there is some problem. Just wait.
Madam, in first one, n equal to minus 7 by 2.
Sorry,
In the first substitution, n equal to instead of
n
the
is equals to minus 3 by 2.
7, so instead of it should be minus 7 by 2. Then only you will get minus 5.
Okay, you are saying if we substitute minus 1 by 2, then we'll get yes,
Minus 3.
yes, yes, yes. After substituting n minus 1 by 2, you will get the value of 1 by 3 minus 3 by 2. Sorry. So this is 2nx zn x z. I'm writing the recurrence relation here.
Ma'am, in the recurrence relation, if
Yes.
you substitute n is equal to minus 3 by 2 in star, so
Okay.
LHS will be j minus 5 by 2 is equal to
Yes.
minus 3 by x, so j minus instead of
Sorry, your
j,
voice is breaking in the last sentence. What are you saying? After
so
substituting in star?
in star with j minus 5 it is a j minus 2, ma'am. Minus 3.
Sorry, I'm not able to. Uh, your internet is. Just wait. Please repeat your question.
J minus 5 by 2 of x is equal to
Yes.
minus 3 by x, j minus 3 by 2
Yes.
minus
Yes.
it is a j minus 1 by 2 of x, madam.
Okay. Okay. Here z of minus 1 by 2. Thank you.
Yeah.
Sorry, guys. This is z of minus 1 by 2. So here this will be the value. What is the value of this is under root 2 upon pi x cos of x, and after substituting z minus 1 by 2 you will get z minus 3 of x. Here after substituting you will get 1 by x z of minus 1 by 2 minus of minus 3 by 2. Is it okay?
Yes, ma'am.
Now what will be the value of z 3 by 2? You can take out this in the right hand side. So 2z minus 3 by 2 of x will be minus of 1 by x z of minus 1 by 2 of x. So take 1 by 2 in the right hand side and write the value of 2 by pi of x cos of x. So this is the value of z minus 3 by 2 of x. You can substitute and you will get the value of z minus 5 by 2. Sorry, this is x. Is it okay? I think there is problem here. If we substitute, then you will get 1 by 2. Am I right? Here you will get 1 by 2. There is little mistake. So you have to calculate this. So what will be the value of this z minus 3 upon 2. You can substitute the value of z1 by 2 and z of minus 1 by 2. Then you will get the value of z minus 3 by 2. z1 by 2 plus 1 by x z minus 1 by 2. Is it okay?
Yes, ma'am.
Yes. Okay, you can put the value. What will be the value? 2 upon pi of x sine of x plus 1 by x 2 upon pi of x cos of x. Now you can substitute this value, then you will get z minus 5 by 2. So I am going to write the value of z minus 5 by 2. Is this correct? Here minus 1 minus is there. Okay. So you can take outside 2 by pi of x 1 by x cos of x plus sine of x. Okay. And here we have also. Now you can take the coefficient of cos of x and sine of x. First of all, you have to take outside, multiplying this. So this is the answer. Is there any doubt? So this is z minus 5 by 2. You have to calculate z minus 3 by 2. So we'll substitute n is equals to minus 1 by 2 in this recurrence relation. So this expression you'll get, and after you can easily find out the value of z minus 3 by 2 of x, because we know the value of z1 by 2 z minus 1 by 2. So the value of z minus 3 by 2 you can calculate in this way, and z of minus 5 by 2 you will get. Is it okay?
Yes, ma'am.
Okay. So let's move to the next question. So the question number 6 is, make use of recurrence relation in the video to show that d by dx x z1 of x is equals to x z naught x. Which recurrence relation will use in this question?
Derivative of x to the power of n jn of x is equal to x to the power of n jn minus 1 of x.
Yes, and simply you have to put n is equals to 1, so you will get the answer. Everyone get the answer? Have you got the answer? Okay, let me write. I think these are quite easy. You can just write the recurrence relation and substitute the value of n is equals to 1. Then you can easily get the expression, can get the required expression. I think there is no doubt in this question. You have to learn these recurrence relation. These type of questions are easy, but you can't solve without this recurrence relation, without knowing this recurrence relation. So you have to learn these type of recurrence relation. These are quite important from your examination point of view. Again, the next question is it's quite similar. Question says, show that d of dx z naught of x is equals to minus of z. Now tell me which recurrence relation we'll use in this question.
Jn dash of x is equal to 1 by 2 jn minus 1 of x minus jn plus 1 of x. Is it?
No, you have to simply tell me the recurrence relation which will connect the negative of n plus 1 and n. Is there any recurrence relation?
Uh, x into jn dash of x is equal to x into jn minus 1 of x minus n into jn of x.
No, no, it is also wrong. Uh, Anyone else?
Derivative of x to the power of n jn of x is equal to x to the power of n jn minus 1 of x.
Yes, but you have to use negative. So the recurrence relation will be x to the power
Negative.
minus of n.
Okay,
Z,
okay.
yes. So these type of question will easily solve if you know the recurrence relation. Either you can get the recurrence relation by so we'll use this recurrence relation. You can see if there is negative of z of something here n, here n plus 1. So you can easily see. So you have to use this recurrence relation You have to simply put n is equals to 0. Then you'll get the answer. Also, you have to substitute x is equals to 1. Sorry, n is equals to 0. You will put it will
Yes.
sufficient z1. Sorry, this is z naught. Now, let's move to the next question. Question number 8. The question says make use of recurrence relation in the video to evaluate integral of x cube z3 of x dx in terms of z0, z1, z2. Okay, I'm going to write the question first of all. Try to solve. So you have to evaluate the integral term x cube z3 in terms of z0, z1, z2. So can we use any recurrence relation in this integral?
Derivative of x to the jn of x is equal to minus x to the power of minus n jn plus 1 of x.
Yes, it is correct answer. So you can use. Okay. Can we write it as now use the recurrence relation whatever he told. Please use this recurrence relation. If we take n is equals to 2, you will get the value of this expression. Is it fine? If we take n is equals to 2 in this relation, you will get the value of the expression z minus 2 z of 3 of x. What will be the value? This will be the value. Okay. Sorry, this is minus 2. Is it okay? I'm just putting the value of z minus 2 z3 of x using this recurrence relation. Now you have to integrate this value. This is also negative. Integrate, please integrate and tell me the expression. So this is the last question. So you have sufficient time. You can calculate and you can tell me the answer. And if there is any doubt, you can also ask me the doubt.
So you can solve by using
Sorry.
solve by using
Solve by using what?
integration by parts.
Yes. You can simply integrate by parts. You can let first and second function and you can integrate. What will be the value of integration? Tell me the integration of this term. You can let this is first, this is second, and you can simply integrate. Tell me the expression after integration.
Of x 5 into x cube x of x dx.
Okay, 5 of integration of what are you saying?
Into integral of 2 of x dx.
Okay. Okay, after integration, first term you will leave and after integrating second term the derivative sign will remove and
Yeah.
here you left with the expression Is it okay?
Yes, ma'am.
Okay. And after derivation of first term, and here plus x की power 4, and also the differentiation will remove, so you will get this expression. You can also again use the above recurrence relation and put the value of this expression, because we have to remove we have to use the recurrence relation in term, and we have to evaluate the integral in terms of z0, z1 and z2. So in the integration we have to remove this term. Again we'll use the same recurrence relation which we have already used in this step. Try to use this recurrence relation. Put n is equals to minus 2, then you will get the value of minus x of 2, z of 3. Sorry, after putting n is equals to 1, you will get the expression. Just wait.
We can write integration of x cube
Hmm.
into x to the power of minus 1 j2 of x dx.
Sorry, please repeat.
Uh,
Your voice is breaking. You're not audible.
in the
Hello.
second term,
Yes.
5 into integral of x square j2 of x is there, na madam?
Yes. This
We
is x
can
squared z2 of x dx.
j2 of x. We can write it as x cube into x to the power of minus 1 j2 of x.
Okay, okay. Fine, fine. Here, if we have to use the expression, what are you saying? Zq
Uh,
minus of,
minus 1 j2 of x.
yes, and you can use the same recurrence relation. Yes, it is correct. Again, you can integrate, sorry, you have to substitute first of all, and then you can integrate by parts. After substituting, this will dy by dx. I think we can use here, because we have the expression z minus of, is it okay? We have to use this recurrence relation. If we substitute x is equals to minus of 2, sorry, um, there is some mistake. Let me try. Sorry, guys. Okay, after substituting here, Okay, can we write it as minus 2 minus 1 and here it will 3. Now it is fine. Now we can use the recurrence relation. Okay.
Yes.
You will use this recurrence relation after putting n is equals to 1. So you will get the expression minus z of 2 of x is x of the derivative of this term. Is it okay? So this will, and minus 1 minus is also there. So is it okay? Now you have to simply again integrate integration by parts and you will get the answer. Okay, I'm going to write the integration. After integrating, you will get, try to check yourself. Is it okay? After integrating by parts, we will get this expression. Again, we will use the recurrence relation here also, so that we can reduce this term also. Again, using the same recurrence relation, you will get the expression. Okay, I'm going to write the expression. So this will be the answer. Is there any doubt in this question?
Madam, please show the last step, madam.
Okay, last
I
step.
think last.
So you have to use this recurrence relation again, because here, okay, I'm going to write the recurrence relation again. So what will be the value of, if we write it as, you have to set the value of integral according to the recurrence relation. So here you have to put n is equals to minus 2. So you will get z of 1 minus 2, this expression. Or you can put n is equals to 0. Sorry, n is equals to 0. You can put n is equals to 0. So that you will get, is it okay? So you have to substitute this with uh, this expression. And again you have to integrate by parts. After integrating by parts, you will get this expression. Is it okay now?
Ma'am, is it last term is plus 15 into integral of j naught of x dx?
Yes, yes. It is integral of z naught of x.
Okay, okay. So integration is not completely removed.
Removed. Yes.
Okay, okay.
Are you getting the last step now?
Yes, yes, ma'am.
So Krishnan,
Yes, madam. Yes, madam.
okay, okay, fine. Now that's all from my side. If you have any doubt, you can ask. Otherwise, we can leave.
Ma'am, I have one doubt.
Yes,
Uh, by using recurrence relations,
yes.
derivative of x into j2 of
X into
j2
G2 of x
is equal to
is equal to
x into j1 of x. How we can show this relation, ma'am?
x into G2 of x is equals to x into Z naught of x.
j1 of x.
J1 of x.
Derivative of x into j2 of x is equal to x into j1 of x is there.
So you have to simply substitute the. We have already solved this question. I think in question number 6. So you have to substitute Z is equals to 2.
Then it will become x square now, madam.
Okay.
But here only x is given.
The question is derivative of x Z2 of x is equals to x of Z1 of x. Is it
Yes, ma'am. Yes, ma'am.
okay? Is there any recurrence relation? Have you remember?
Uh, not a
Okay,
solution.
I look for this uh, type of problem, and we can discuss through WhatsApp also. You
Okay,
have
ma'am.
my WhatsApp number.
Please
I'm
give
going
me.
to write.
Okay.
Okay, after recording is off, I will give the number.
Okay, ma'am.
So, is there any doubt in these problems?
No, ma'am.
Okay, okay, fine. Anyone? Okay, I'm going to write some question from my side. You have to give the answer. Just wait. Okay, let's discuss some problems because we have 30 minutes more. So, have you learned about equations reducible to Bessel's equation? We have already discussed in week 5 lectures. Okay, you can see
Yes, ma'am.
from there. The next question is, okay, try to solve proof, because we have already used this expression and you have also learned to prove in your lecture series. Can anyone tell me how to prove this expression? Or, yes, tell me how to show this expression. What is the definition of Jn?
Summation infinity minus 1 x by 2 plus 2r
Yes,
1 by gamma of x into r factorial.
yes. We can also write the same expression in the expanded form as, and so on. Is it okay? This is
Yeah,
the same expression.
yes.
Now you have to just simply replace n with minus 1 by 2. You will get the expression. X to the power minus 1 by 2, 1 minus x square. Here, if we substitute, what will be the, we can write 2. Simply, we left with 2. So, we can write 1 into 2. And after simplifying this term, you will get 1, 2, 3, 4. That means 4 factorial. What what is the value of gamma function 1 by 2? Under root pi.
Yeah.
Yes. And this is the expression of cos of x. Similarly, you can show z 1 by 2. Now, if you have the question like, yes,
Then the first line.
hello,
Yes, ma'am. Audible to me?
no, you are not audible. Please speak loudly.
Please explain the first line.
Okay, first line. So this is the expression of Zn of x. Have you learned about the Bessel's function?
Yes, ma'am. But in summation notation,
Yes, you will expand the summation, you will get the same expression.
okay, okay, okay.
Yes. Similarly, you can show z 1 by 2 also. Now, if the question is something like, To show, you have to show this expression. So simply squaring and adding the equation. Let's say this is equation 1, and what will be the value of z1 by 2? We have also used this expression. Simply squaring and adding, you will get the answer. Okay. So these are the problems. I think no any particular problem is there from my side. Can you prove one more question? Can you prove this? Use the recurrence relation. You can use these two recurrence relation and you can show the expression. What will be the derivative of this expression? Can we write it as 2 zn dash of x plus 2 zn plus 1 zn plus 1 dash. Now you can use these values with the help of this expression. You can replace n is equals to n plus 1 and put the value here, and after simplification you will get the expression. Put the value and get the answer.
Madam, left hand side,
Sorry,
left hand side.
left hand side, it is 2 in bracket n by x zn square minus of n plus 1 upon x zn plus 1 whole square, zn plus 1 square. Okay, I'm going to write
Not
again.
that. Not
Let
that.
me.
Of x a and dash you are given. No? Both equation you are given same.
Both equation are same, but recurrence relation both are true.
Different.
One
Okay. Okay.
recurrence relation is okay. Sorry. This is n plus 1. So you have to replace n with n plus 1 so that you will get the value of this, and you can substitute the value of zn dash with the help of this expression. Then you will get the expression. You will get the answer. Sorry, replace n with n plus 1 in this expression and substitute zn dash with the help of this expression using these two expressions. Have you got the answer? Okay, let me write 2zn. What is zn dash? It is n upon x zn plus 1. What is the value of zn plus 1 dash? After replacing n with n plus 1 in equation 1 in this expression, you will get minus n plus 1 upon x zn plus 1 plus z of n. Now you can simplify and then you will get the expression. Just taking these terms with this. Is it fine? You have to just simplify the above expression, then you will get the answer. Okay, one more question. We have 13 minutes left, so we can solve one more question. Okay, use the recurrence relation. After differentiating this by parts, letting this is first, this is second, and you have to differentiate by parts, and after differentiating you have to use the recurrence relation. Just wait. And the second one is you can replace n with n plus 1 here and use this value and you will get the answer. Okay, I'm going to differentiate the above expression, then you will get, is it okay? This is the differentiation of this term. Leaving this, differentiation of x is 1. After leaving x, the differentiation of the product of zn plus 1 is this. And now we can use the recurrence relation x zn from here, and x zn dash n plus 1 you can replace here n with n plus 1. Then you can substitute the expression x zn plus 1 dash. After substituting you will get the answer. The value of x zn dash is n zn minus x zn plus 1 plus zn. The value of x zn plus 1 is you have to replace n with n plus 1 in this expression, then you will get the expression x z n plus 1 dash, and I am substituting the value of z x z n plus 1 dash. Now you have to just simplify. So these terms will cancel out after taking x outside. So you will get the answer. Is it okay? Hello?
Yes, ma'am.
Okay. Thank you guys. That's all
Okay.
from my side. We can leave now. Is there any doubt?
Thank you, ma'am.
Okay, okay.
Check that number.
Sorry.
Shared your contact number to WhatsApp
Okay,
number.
okay. Just wait.